Hey everyone, I hope you had a good spring break. Today is day 15 of Math 133. We're going to work on the Chapter 7 project. And yeah, like I said, I hope everyone had a good spring break. Um, I've graded your midterms, so go and take a look at that. And after we get done with the project today, if anyone has questions on the exam, we can go over those. Um, so uh, I haven't graded your Chapter 6 review yet or your cumulative review. So uh, yeah, still working on those. But those aren't going to change your grade drastically. Those might adjust it up or down by like 1%. So yes, take a look at your grade. So most of the time, people do a little worse on the midterm than the worksheets and the projects, and that's because with the worksheets and the projects, we're working on those together, right? We're going to do the Chapter 7 project here today. So if you do see that your midterm is a little lower than your previous grade had been, that's to be expected. Now, if your grade at the moment is somewhere in the 80s or 90s, 80 or 90%, you're fine. So, it might have gone down from where it was. Like, when you're doing the worksheets and the projects with me on Zoom, we make sure that you get all the questions right, or at least most of them. And so, maybe you had like a 95% before the midterm, and now you're down to an 85%. That's okay. You're still in a good spot. That's probably about where you would expect your final grade to end up. So, yeah. Now, on the other hand, if your grade is somewhere in the 70% range, so like from 70% to 79%, you're still fine. You're passing the class. You definitely are going to want to make sure that you come to all of Zoom, get everything turned in on time, and study for the final. But you'll be fine. Okay, you should be able to pass the class. Now, on the other hand, if your grade is somewhere in the 60s, so you're at a 65%, um, that's a failing grade at the moment. Okay, but you're not out of it yet. So same thing. Make sure you come to all the Zoom sessions. Make sure you get all of the worksheets and the projects turned in on time so you don't lose any points. Because when you turn something in late, I'll still grade it, but you're losing points for every day that it's late, and those are points that you don't need to lose, right? So make sure you get things turned in. Excuse me. Make sure you get things turned in on time, and then make sure that you you know study for the final. So if your grade's lower than that, if your grade's in the 50% or lower, um, you are not mathematically eliminated from, passing the class. But you should definitely consider uh, is withdrawing from the class a better option because withdrawing from the class will make sure that you don't hurt your GPA with a failing grade. So feel free to, reach out to me if you have questions or if you want to talk about anything. You can also talk with your navigator. But um, now that you've taken the midterm, you know what to expect for the final. The final is going to be very similar to what you saw on the midterm. Uh, and so uh, the final is also worth 30% of your grade. So, um, uh, yeah, anyway, hopefully that all makes sense. So, uh, yeah, let's see, what other announcements are there? So, back on day 14, so in Canvas, if you click on day 14, which is the day we had the midterm, so in here, there's the midterm exam, but there's also lecture notes. Those lecture notes are due today. If you get them turned in by midnight, then you'll still get full credit, even if it says, it's due at 6 p.m. So make sure you get those lecture notes turned in. Um, if you're going to end up turning things in late, the lecture notes, you don't want to turn the lecture notes in late because every day late, I take a point off. And you'll notice that this one, for example, the 7.3 lecture notes is only worth 1 point. So if you turn it in tomorrow and I take a point off, well, you're getting zero, right? So uh, if you are going to turn something in late, the worksheets are worth a lot more points, and so losing a point that here or there isn't as bad. But yeah, anyway, make sure you get your lecture notes turned in on time. Uh, so there's that. So now that the midterm is over, there's kind of a shift in the class after the midterm, where it's not a huge shift. We're still going to have, one assignment that we work on each class. But it does, in my opinion, feel a little bit at a slower pace, which is good. But the material we're going to be covering is a little more complicated, in my opinion. Okay. So you still want to make sure you're coming to the Zoom sessions, still want to make sure that you are asking questions and participating and not just, turning on Zoom and zoning out. Okay. So, okay. That all said, in 2 weeks on March 24th, we have our candy project. So what is that? I'll send a note and remind, and we'll also talk a little bit more about it as we get closer, but you're going to need to go out and purchase some M&Ms and M's and some Skittles. You can do it now, but it's still 2 weeks out, so if you go and buy them now, I don't want them all to get eaten right away. So, um, yeah, I'll send a note and remind, so be on the lookout for that. Okay. Um, okay, so I think that's everything. Let's jump into the Chapter 7 project. So our home run distance is normal. So in Canvas, if I click on the Chapter 7 project, there's a couple links in there that we're going to need. One of them is the Google document where we're going to fill in all of our answers. So we're going to click on that, and it's going to open up this. Okay. So make sure you do File, make a copy, and it's 2026, and there we go. Uh, we're going to put it in a different folder, not the old projects not used anymore folder. We'll change it to, let's put it in here, or you can put it in my drive, that's fine. So file, make a copy, and now we can enter our answers. Um, and then we have a link to the data in StatCrunch, which is on the uh, Google document, but it's also back over here in Canvas. Either of those links is fine. So we need to get to the home run 2029, or sorry, home run 2019 data. So we'll click on that. Make sure you sign in. So sign in for StatCrunch, right? I've already signed in. Um, there's also a video in Canvas on how to do the assignment. You can probably skip that because we're going to work on it together today, and we'll make sure, we fill everything in. So, okay. So our home run distance is normal. So, um, first of all, we've already talked a little bit about the normal curve. So the normal curve is a bell-shaped curve, right? And uh, we looked at it a little bit in um, our exam notes packet, right? On the very front, page 253. Uh, I don't have my exam notes packet in front of me. Well, that's annoying. Um, that's okay. Page 253 in your exam notes packet, there is a bell curve, and you'll remember that um, one standard deviation away from the mean is 68% of our data, and then two standard deviations away is 95% of our data, right? And then 99.7 was three standard deviations away from the mean, right? So, um, those are the whole numbers, 1, 2, and 3. Um, but we're going to start looking at some other uh, distances away from the mean um, in chapter 7, where we can say, like, okay, where does 90% of the data land? Where does 80% of the data land? Every probability, every percent has a corresponding z-score with it, and vice versa. Every z-score has a corresponding probability. And so we'll be switching back and forth between probabilities and z-scores in chapter 7. Okay. Um, so the idea with the bell curve, though, is um, if you were to make a histogram of all of the different frequencies of some data set, um, sometimes it's skewed left, sometimes it's skewed right. Yeah, and we've seen that, and sometimes it's symmetric. The normal curve is a very special resulting histogram where the data is symmetric, okay, and it's all kind of grouped in the middle, okay. So anyway, there's not a ton of data sets in the real world that end up being normal. But there is a very special, we're going to talk about in chapter 8 that if you it doesn't matter what data set you're looking at, if you look at uh the distribution of samples, so if you were to take multiple samples of any data set, those end up being a normal distribution, which is a very interesting thing. And it's one of the core theorems, one of the core concepts in statistics. Anyway, that all said, uh, there are some data sets that look normal, and we're going to see if home runs from 2019 look normal. Okay. Okay, so all that said, let's actually look at what are we doing for number one. Number one, draw a frequency histogram of the home run distances and select bins, start value of 250 and width of 20. Okay. Um, okay, sounds good. So let's come over here. So these are all the home runs that were hit in 2019 by Major League players. Um, and looks like they're sorted by distance. So the furthest distance was 505. Looks like we've got what do we got? We've got 600, 6,000. 6,000 home runs were hit in 2019. That seems like a lot. Shortest one was 251. I'm not sure if that was in the park home run or if that was just that had to have been in Boston over the Green Monster. So um yeah, that seems like a lot of home runs. So we're gonna do a histogram. So we're gonna do a graph histogram. Graph histogram. Okay. We are gonna select the distance for our uh metric that we're for our column. Okay. Now, if you do it right now, if you hit compute right now, don't hit compute, because we want to change a couple of things. If you do it right now, it looks fine, but we're going to make a couple of changes to it. So graph histogram, select distance, and we want to start at 250. So here where it says start, we're going to put 250 in here. And the reason why is because we're going to start a little lower than the lowest one. Okay. Um, it looks like StatCrunch is smart enough to start at 250 anyway, but uh we if this was like 255, I wouldn't want to start at 255. So and then a width, we're gonna do a width of 20, okay? And then we'll hit compute. Okay. So here is our histogram. I actually think I like the histogram they gave us first a little better. Yeah. The bars were a little bit thinner. Yeah, except the widths they gave me here are weird. This is a width of 12.5. Yeah, that's weird. I would have done like a width of 10. Anyway, width of 20 is fine. That's what we're going to do. So again, what I did, graph, histogram, select distances. I put in the start at 250. I put in my width at 20, and then I hit compute. Okay. And we will grab a screenshot of this. Okay. Let's come over here to StatCrunch, and we're going to put it in right here. All right. Oh, shoot. I put it in number 2, didn't I? No, I did. Did I put it in number 2? No, I put it in number 1. Why is it doing that? What if I put it right here? Hmm. All right. Well, looks like so Rachel, yours did the same thing. All right. Well, that's fine. If you I bet when we put in so for question 2, we get the mean the standard deviation. Okay. Um, I'm not sure why it's doing that. I'll have to research, but that's okay. Um, let's just paste it in there and we'll keep going. Okay. So we'll have to come back up here to do number 2. That's weird. I don't know. Have you seen that before, Elaine?
No, I'm not sure. Other than like, is it
Mhm.
limited right there? Like, I don't know.
Oh wait, now
You know
now
so
number
much
two
more
is
than I
down
do.
here.
Haven't
Okay.
seen it do that though.
That's okay. Now my number two's down here. Weird. All right. Anyway, wherever your number 2 is, let's finish number 1 first. Um, comment on the
Do you
shape of
want
this
them?
distribution.
You'll be able to
What?
see what you'll be able to find it. Do you need
Yeah,
them?
yeah.
Okay.
No, I'll just grade it. I'll just grade it in whatever order you turn it in. So,
Okay.
okay. Comment on the shape of this distribution. Is this skewed left, skewed right, or symmetric? What do you guys think? Yeah, Nicole says symmetric. I agree. Looks symmetric to me. Um, we do have one outlier at 251, which is down here, and you can't really see it very well, because it's only one. And so is that dragging it down? I don't think so. It doesn't seem like it's that big of an outlier. It's not like way over here. Also, a single outlier is fine. It's when you have a lot of outliers, but that's number 1. All right, so number 2, go find number 2 wherever it is, if it's above or below. Determine the population mean, standard deviation, and size for the home run distances during the 2019 season. Okay, so let's go back over here to StatCrunch, and we'll do stat and then summary stats and columns. Stats, summary stats, columns. Still selecting distance, and um, we're going to select the n because that's the size. That's how many there are, the sample size. Sorry, population size, because we're we're doing a population because we are looking at all the home runs from 2018. Okay. And then we want the mean. So let's that. And then we want the standard deviation. But do we want, we don't want the regular standard deviation because we're not doing a sample here. We're doing population. So we're going to scroll down here to the unadjusted standard deviation. You're going to hold your control button and click unadjusted standard deviation. Don't hold control while you scroll, just when you click here. Okay. So I want these three: n, mean, and unadjusted standard deviation. Okay. And we'll hit compute. Okay. And you can get a screenshot of that, or you can just select everything there and copy it into question number 2. Yeah. And if your question 2 answer is above your question 1 graph, that's fine. I don't know why Google Sheets is being dumb, but there it is. So we had 6,677 home runs that year. The mean was 400 feet. We measure distances in feet in baseball, and give or take 26 feet. Draw the normal curve with the mean and standard deviation found in part 2 on the frequency histogram from part 1. Do this by selecting overlay distribution and choosing normal and using the mean and standard deviation found in part 2. Also select the option to add value above the bar and select a bin start of 20 and a width of, 250 and a width of 20. Okay. So we're going to redo the histogram. Okay. That's what this is saying. And we're going to add some stuff. Okay. So let's go back to StatCrunch and redo our histogram. Okay. So I'm going to close this histogram because I don't want to get myself confused with the old one. But I'm going to go back over here to graph histogram. You could have just selected options and edited the one that was there. That's fine too. So I'm going to select distance still. Okay. I'm still going to select my start at 250 and my width at 20. Okay. But right here where it says display options, I'd like to do an overlay distribution. And you'll click the drop down and select normal. It wants to know what the mean is. So that's 400.22. Where did that, so it knew that I had typed that in before. So, and then standard deviation of 26.26. Okay. And also this one, value above the bar. Okay. So stat, or sorry, not stat, graph histogram, select distance, start at 250, width is 20, drop down your overlay distribution, select normal, mean is the mean that we found before, 400.22, standard deviation 26.2, that 5 has to get rounded up because of the 8, so 2.26, select value above the bar, and hit compute. Okay. So all this is doing is it's graphing the same histogram we had before. It's adding the numbers at the top of the bars so that we can see how many there were. There were 1,921 home runs that were between 390 and 410. Yeah, we shouldn't have done a width of 20. We should have done a width of 10. That's weird. Okay. And then uh the sorry, Eva. You're asking about these ones right here. And then this red line here is a normal curve. And it's just a normal curve that we've overlaid on it. It's not actually connecting the bars. If we had put in, the wrong number here, right? If we had put in 300, uh, it would have grafted in the wrong spot. So like this, okay? So it's not actually uh, it, it's not actually putting the like connecting the bars. It's just putting it on top so that you can compare them. um, okay, but that all looks good. Let's grab this and get a screenshot of it. Question number 3. Oh, I missed. I cut off some stuff. Let's try that. Question 3. It almost did it right. But number 4 still here. That's weird. All right, there's that. Part B. All right, part B. Do you think a normal model would describe the variable distance? Yes or no? So yes, the histogram closely. So yeah, so I think the answer is yes, because you can see like this curve, fits on these bars really well. And if I had looked at a smaller width, I think it would have fit even better. So like if I had done a width of 10, yeah. Oh, maybe not. So got a little bit of a skew right there, but the rest of the bars fit pretty good. So okay.
Do you want them to just do the 250 and the 20?
Yeah, yeah. I was just messing around with the 10.
Okay.
Yeah. Yeah, your graph should look like mine on
Yeah.
this
Okay.
page right here. So yeah, I was just saying that like 20 feels weird to me because one of the bars is 390 to 410. Um, I don't know. Maybe a better way to have done it would have been if I didn't start at 250, if I'd started at 240 and done a 20. But yeah. Um, yeah. I'm just messing around. You don't need to do any of that.
But it's fun, just because you can.
Yeah, do what it says on the paper. It says start at 250 with a 20. Okay. Okay. So part B, do you think a normal model would describe the variable distance? I think yes. This histogram matches really well with this normal curve. This histogram's not skewed left, not skewed right. Okay. Now, even if your data is symmetric, it doesn't necessarily have to match up with normal. There's a uniform distribution, which is symmetric. That's where all the bars are the same height. That's symmetric, but that doesn't match up with this bell curve. So, all right, question number 4. Let's let's look a little closer at this and see uh how good is this fit? Is this normal curve compared to the histogram? Find the relative frequency with which a home run distance between 350 and 389.9 feet is observed. Use the frequency histogram. Show your work and give 4 decimal places. Okay. So relative frequency, you'll remember from chapter 2, was frequency divided by the total. Okay. So 350 is right here. And then 389.9 it's 390 is right here. So these two bars are the distances from 350 to 389.9, right? 390, if the distance was exactly 390, it would fall into this bar. We're not counting those. So I need these two bars. So this bar is 699. This bar is 1415. So I need to add those together. So this is what it would look like. 699 plus 1415. That's going to give me my frequency. But then I need to put that in parentheses and divide by my total, which was, how many home runs was it all total? 6677. That's my total. Right? So that's the formula right there. Okay. So relative frequency is your frequencies divided by your total. And I have these two frequencies because those are the two bars they want me to look at. So I'm going to type this into our calculator. And I get 0.3166. Okay. We want 4 decimal digits, so 3166. Now, your relative frequency should always be a number between 0 and 1. Relative frequency is uh is a probability. Okay. We've talked about probability before. Um, Relative frequency is interchangeable with probability. Okay. And probabilities, we remember, are always between 0 and 1. So okay. So you could write that as a percent if you wanted to. I'm not going to. I'm going to write it as a decimal 0.366. Okay. So 31% of our data is in those two bars. Now, that is the relative frequency. I want to compare that to what the normal curve says. So the normal curve is a prediction of if your data was in this, very nice distribution. We can use StatCrunch to find what percent of the data falls in between those two distances by calculating their z-scores and then using uh, the normal curve to say, okay, from here to here is this percent, right? Just like, you know, one standard deviation is 68%, two standard deviations is 95% of the data. Okay, same idea. Okay, so question C, use the normal model to find the area under the normal curve between 350 and 390. Use stat, calculators, normal, copy and paste the chart with probability. Okay, so stat, calculators, normal. We're going to come over here, stat, calculators, normal. Okay. And we're going to do between, and we want to do a mean of 400.22, standard deviation of 26.26. Our distances will be 350 and 390. Okay. You could put in 389.99. It's not going to change it drastically. It's going to be the same. Okay, so let's hit compute on that. And I get 0.3207. 0.3207. Okay. So I'm going to grab a picture of this here. And we'll put that into part C. So question 4C. Put that right there. All right. So, and this is what we're going to be doing all of chapter 7 is stat, calculators, normal. So chapter 7 review that we're going to cover on Thursday, we're basically going to be messing around with this normal calculator like the whole time. Okay. So standard is if you want to look at above or below something. Between is what I want because I want to look between 350 and 389, or sorry, 390. Now the normal curve has a mean of 0 and a standard deviation of 1. That's what you'll use if you have z-scores. I don't actually have z-scores here. I have distances. So I need to make sure I put in the correct mean, which is this one, 400.22. I need to put in my correct standard deviation, 26.26. Okay. And then what do I want to look at? I want to look between 350 and 390, right? So If you put in 389.9, it's a little bit different. That's okay. You can put in 390. I think that's what they asked us to do. So, um, all right. And so we're going to grab a screenshot of this. Okay. Compare and contrast the values that you found for 4A and B. Somehow, somehow there we go. I somehow added a B. Sorry about that, guys. 4A was 0.3166. That's the relative frequency. Okay. That's the actual result. Okay. The normal calculator is a prediction and it says that we should get 0.3207. Okay. Those are very close. 3166 and 3207. Yeah, those are off by like, let's see, this is 31%. This is 32%. So they're off by 1%. They're actually off by less than that because this is 31.6 and this is 32.0. So they're off by less than half a percent. Okay. That's so close that they're pretty much the same. So the values are extremely close. Okay. Why does that matter? It matters because if this was a skewed data set, then they would be much farther apart. Our actual data would be skewed one way or the other, and our prediction would be much farther off. Okay. We saw that before when we were looking at like the linear regressions, when you had like a outlier that dragged your line really far away, it made our predictions, it made our residuals really bad. Okay. If your prediction is very close to the actual data, then that means it's an excellent prediction. So the normal curve here is an excellent prediction for where our data sets are landing. Sorry, our home runs. Okay. We have question number 5. Find the relative frequency. So question number 5 and question number 4 are pretty much the same. Okay. We want to compare what does the data say, the histogram, and what does the normal curve predict. So they're very similar. Question number 5. Find the relative frequency with which a home run distance is over 430. Use the frequency histogram, show your work. More than 430. I don't know what this means. I don't know why that's there. Okay. 430. So 430 is right here. So there are 3 bars past that. There's the 669, the 160, and the 29. Yes? 669, 160, and 29. So we need to add those up. Did I get that right? 669, 160, and 29. Yes. That'll give us the total number of home runs that were 430 feet or longer. Okay, those are your bombs, right? Those are way over the fence. Um, and then, oh, we need to divide by our total. And let's put that into our calculator and see what we get. So 12% of our home runs were 430 feet or more. So 0.1285. Okay. Now that's the actual number. 12%, 12.8% of our home runs were 430 feet or more. Let's see what the normal curve predicts. probably going to be pretty close because our normal curve looks pretty close. Use the normal model to find the area under the normal curve to the right of 430. Use stat calculator's normal. Copy and paste the chart with the probability. So we're going to come back over here. You can either restart this by doing stat calculators normal, or I'm just going to use the one we had before. I don't want between this time. I want to switch it back over to standard. Standard is what you use if you want everything to the left or everything to the right. And in this case, I want everything to the right of 430. So we'll put in 430 here. Your mean is still 400.22. Standard deviation is still 26.26. Okay. Um, and we're going to put in 430 right here. And then right here, we're going to switch this because we want greater than 430. Okay. If you do less than 430, you get 0.87, which is not even close to the 12% we had a second ago. We want greater than. So greater than, and then we're going to grab that. Okay. And we'll paste that into question 5B. Okay. So standard, mean, standard deviation greater than 430, hit compute, and I get 0.28, 0.1284. Okay. Um, Compare and contrast the values from found for 5A and 5B. So this one was 0.1285. This one is 0.1283. Yeah, those are off by less than 1/100%. So those values are even closer than they were for question 4. Yeah. So, all right, those values are even closer. All right. So lastly, question number 6. Uh, which type of model, histogram or normal curve, do you think is more appropriate for analyzing home runs in the year 2019? Just 2019. What do you guys think? Curious what your thoughts are. Histogram or normal curve? What do you guys think? Yeah, normal curve with 2 double question marks. Okay. I mean, shout out your answers, right? Today is not test day. I know. So we took our midterm 2 weeks ago, and on test day, you want to get the right answer because I'm going to grade it and it's going to affect your grade. But today, it doesn't. If you get a question wrong, it's no big deal, right? Um, so both of them are good models for 2019. As we saw a second ago, the values for looking at the relative frequencies versus the probabilities from the normal curve, they were extremely close. Okay, they weren't perfectly accurate. Like they were off by like 0.5% or so, uh, which is fine. Okay, I'm gonna go with the histogram here because uh, it is the actual data. So, what I mean by that is we have the 2019 home run population. We have all of them. There's 6,000 home runs, and we didn't have to do a sample. We were able to look at the entire thing, okay, and find the actual mean, the actual standard deviation, the actual relative frequencies. Now, the normal curve is allows us to do predictions, and those predictions were really close. Okay, and so if you put normal curve here, I'm probably not going to mark you off for question number 6. Okay, because the normal curve is an excellent prediction here. Now we have seen cases where like you had like a weak positive correlation or a weak negative correlation. It's like, okay, your correlation is not great. Okay. Your predictions are not great, right? When you have a strong correlation, it's like, okay, those predictions are really good. They're still not perfect. Okay. Um, but yeah, uh so I'm going to go with the histogram just because it is the perfect, it's the actual data. Now, for question for part B, which type of model, histogram or normal curve, do you think is more appropriate for inferring about home runs in years other than 2019? So, for like year 2020. So, all right. So, Rachel says normal curve. Yeah, Nicole agrees. Yeah. No more question marks for Nicole on this one. Definitely normal curve. Yeah. No, I agree. Uh, I think that the normal curve is a better model because it uh, predicts the results, even though we don't have the data, right? So if you were to ask me how many home runs were over 430 feet in the year, uh, 2025, last year, I don't know. I don't have that in front of me, but I could use my normal curve and say it was probably close to 12.8%. Okay. So the 20, if you knew what the mean and the standard deviation was for the population or for a sample, I would be able to get even more accurate. Okay. Even though I don't have the actual data sitting in front of me. Okay. I think StatCrunch does have the 2013 home run distances, so you could go and you could double check that, right? But anyway, um, that's my answer. Uh, if you have the actual data, a histogram's probably a little bit better just because um, it's the real numbers, okay, as opposed to predictions. But that's it for our Chapter 7 project. Um, Make sure you share and change the general access to anyone with the link, and then copy that link to your clipboard. Come over here to Canvas and click web URL. We'll paste that right here and hit submit assignment, get our confetti. All right. I got trophy confetti and we're good. Okay. Now, I'm going to stop the recording. And if anyone has questions on the exam, we can go over those. Uh, yeah. Otherwise, I'll see you on Thursday.